Okay, good afternoon all of you. So again we have some problems, especially on sequences and series. Actually, for appearing in the exams of JEE mains and advanced, not only conceptual knowledge is required, but also problem solving is a very important phenomenon. And you need to solve some different types of problems for appearing these type of exams. So that was my focus. And I want to solve some important problems. That is not enough, but I have tried my best to give you the knowledge on these problems. So let's start with problem number 1. So if x equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, etc., and y equal to 1 upon 1 square, 3 upon 2 square, 1 upon 3 square, etc., and z is given by 1 by 1 square minus 1 upon 2 square plus 1 by 3 square minus 1 by 4 square, etc. Then you have 4 options. X, Y, Z are in AP, Y by 6, X by 3, Z by 2 are in AP, 6Y, 3X, 2Z are in HP, none of this. So first of all, you have to observe the problem very carefully. You have a X, you have a Y, you have a Z. Now, you see, first I will take y minus x. If I take y minus x, you look at that, 1 by 1 square cancelled and 1 by 3 square cancelled. So these terms are cancelled actually, and you are remain with 3 by 2 square, 3 by 4 square, etc. So let me write that thing. So observe very carefully x and y. So I am using y minus x. I am using y minus x. So y minus x is basically, if you take 3 common, that will be 3 times 1 by 2 square, 1 by 4 square. Because you see this y minus x, this 1 by 1 square, 1 by 3 square, 1 by 5 square, these terms will get cancelled. Okay, and you are remain with 3 by 2 square, 3 by 4 square, etc. So I am taking 1 y minus x plus 1 by 6 square plus, etc. Okay, and if I write x minus z, look at that, your expression again, go back to your expression. If I take x minus z, again you have 1 by 1 square cancel, you will have minus 1 by 2 square, 1 by 3 square cancelled, you will have 1 by 4 square, 1 by 5 square cancelled, you will have 1 by 6 square, and so on. So it's gonna be 1 by 2 square plus 1 by 4 square plus 1 by 6 square plus, etc. So this is same as the right of y minus x, only thing is that 3. So we can write y minus x equal 3 into x minus z. So that is by observation you have to do. So this is very simple form now. So you can write 4x equal y plus 3z. Okay. Now I will divide throughout by 6. So it will be 2x over 3, y over 6 and z over 2. So look at that, it looks like AP, because for AP twice b equal to a plus c, that is the condition for ABC are in AP. So y by 6, z over 2 and x over 3, y by 6, x by 3 and z over 2, that is the sequence. Y by 6, z over 2, x by 3, they are in AP. So let's go back to the options. Yeah, it's number 2, B option is correct. Okay, y by 6, x by 3 and z by 2 are in AP. So that's the, you just observe the problem and try to figure out. Let's move to the second problem. Yeah, this is also very interesting problem. If A1, A2, A3, A4001 is in AP, it's look like a very large series such that 1 over A1, A2 plus 1 over A2, A3 plus etc. 1 over A4000, A4001 equal to 10, and it is given A1 plus A4001 is 50. You have to find out the difference of A1 minus A4001, that is equal to. So what I will do, I will take this A1, A2 all are in AP. So I must write A2 minus A1 equal A3 minus A2 etc. That must be equal to the common difference if you take all. So that must be equal to D. So I will use this, and let me write this one. So that I will start from this expression. So I am writing here, this is number 2. So number 2, 1 over, so I am writing 1 over D, 1 over D, and it's D A2 A1, the expression, given expression, look at the given expression, 1 over A1 A2, 1 over A2 A3 etc. So I'm writing D, I'm writing D in the numerator, and 1 by D is, we have adjusted 1 by D outside, so it's no problem over there, and I'm writing D over A2 A3 etc. Okay, and on the right you have 10. So what I'm doing, I'm writing this D as A2 minus A1 by A1 A2, A3 minus A2 by A2 A3 plus etc. The last term was, okay, this one A4001 minus A4000, okay, over A4000, A4001 equal 10D. I'm just cross multiplying D on that side. Now if you split into two parts, if you split A2 by A1 A2, A1 by A1 A2, so that's gonna be A1 by A1 minus 1 by A2 plus 1 by A2 minus 1 by A3 and so on. You split all the terms, and on the right you have 10D. Now look at that, all the 1 by A2, 1 by A2, it will get cancelled, plus minus get cancelled, 1 by A3 get cancelled. You are remain with only, you are only remain with 1 by A1 minus 1 by A4001. That's it. You are remain with this only, and that is equal to 10D. Okay. Now again I am writing, if you simplify A4001 minus A1 over A1 A4001 equal 10D. Now writing the nth term formula, A4001 can be written as A1 plus n minus 1 into D. A1 plus n minus 1 into D. So that's equal 4000 D over A1 A4001. Okay, equal 10D. That's it. Because why I am writing this? Because the nth term formula I am using, A4001 is equal A1 plus 4000D. Okay, 4000D. So A4001 minus A1 would be this one. So if you simplify, you will get A1 4001. The product will be equal to DD cancel. That product will be equal to 400. 400. So that's one of the result, and it is given in the problem. it is given that, look at that, A1 plus A4001 equal to 50. So it is given A1 plus A4001 equal to 50. So now let us calculate modulus of A1, 4000 minus 4001 whole square, that is A plus B whole square minus 4AB. So 2500 minus 1600. So that is 900, and if you take the positive square root, that will be 30. Okay, that will be 30. So this is your answer. This is your answer. Let's go for the options. Yeah, it's B, option B. Okay, clear? So this is very interesting problem. Next, I will go to next problem. I will go to number 3. If A1, A2, A3, etc. are in GP, where AI belongs to C. C means set of complex numbers. The complex number. C is the set of complex number. It can be complex. Having R as common ratio, then such that summation k equal to 1 to n, a 2k minus 1 equal to summation k equal to 1 to n, a 2k plus 3 not equal to 0. Then the number of possible values of R is, that you have to find out. Now look at that. This summation, first observation is this summation. The first summation will give you, if you expand, a1 plus, for k equal to 1 it will be a1, for k equal to 2 it will be a3, for k equal to 3 it will be a5. So a1 plus a3 plus a5, etc. a2n minus 1. Okay, and the next one will be a5, the summation a5, k equal to 1 it will be 5, k equal to 2 it will be 7, and so on. It will be a 2k plus 3. Okay, now we can write just one observation. We can write a2 as a1r because they are in GP. a3 can be written as a1r square, a4 can be written as a1 r to the power 3, and so on. Okay, that we can write. So let me use this technique. So I'm equating this one because these two summations are equal. So I'm writing a1 plus a3 plus a5 plus etc. a2n minus 1 equal a5 plus a7 plus a2n plus 3. Okay, these are equal. These two summations are equal. So now I'm writing a5 as a1 r to the power 4 because the first term is a7 as a1 r to the power 6, correct? Okay, and so on. So you can take r to the power 4 common, so it can be written as a1 plus a1 r2 r squared and a1 r4, etc. so on. So it is nothing but a1 r square is nothing but your a3 third term, a1 r to the power 4 is nothing but your a5, and so on. That means these two terms, and so on, and the last one will be a2n minus 1, exactly similar on the left, 2n minus 1. So this and this term will get cancelled. So r to the power 4 equal to 1. So what are the values of r? R equal to plus minus 1 and plus minus I. I is the iota root over minus 1. So these are the, so you have 4 values only. You have 4 values. So then the number of possible values of R is 4. So your option will be C, third option. Okay. So maybe initially you was surprised by the fact that it belongs to complex number. So no, it is not related to complex number, but it's a very simple series. Just the only complicated part is the summation. Maybe it's look complicated, but you can solve that easily using the summation and the series technique by GP. Next, yeah, next problem. You have 3 summations. Summation I equal to 1 to infinity, summation j equal to, so you have infinite terms. Summation j equal to 1 to infinity, summation k equal to 1 to infinity, 1 over a to the power I plus j plus k is equal to, you have to find out the summation. Maybe don't worry about that. It maybe looks very awkward. The expression looks very complicated, but don't worry. It is very simple to solve. But there may be some questions like this, but don't worry. You have to attempt that summation. And it is given that mod a is greater than 1. So one observation is that here you have 1 by a to the power I plus j plus k. If mod a is less than 1, then 1 by mod a is 1, mod a is greater than 1, 1 by mod a is less than 1. Okay, and it is positive because it's modulus. So 1 by mod a lies between 0 and 1. That is the first observation. Next, let us simplify this expression. So I'm writing this expression, summation I equal to 1 to infinity, summation j equal to 1 to infinity, summation k equal to 1 to infinity. Okay, so let me write here. Yeah, so summation, you have 3 summations, 1 over a to the power I plus j plus k, that is given. Okay, so I'm writing summation, 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 1 over, it can be written as I into a to the power j into a to the power k. Okay, by using indices. Now I will take 3 summations because you have a product separately. So I will write, okay, this goes to infinity. Okay, I equal to 1 to infinity, and summation, because it's only on summation I, its sum is over I and its power is over j and its power is over k. So you can take this summation separately. So a to the power j is from 1 to infinity, and you have summation k equal to 1 to infinity 1 over a to the power k. Now you take the, this is infinite GP series, infinite GP series. You can see first term will be 1 by a, second term will be 1 by a square, third term will be 1 by a cube, and so on. It's infinite. And 1 by mod a is less than 1, 1 by mod a is less than 1, that already we have done initially by observation. So you can write the sum as a by 1 minus r. So its sum of the series will be this one. This is the sum of the series. For the second case, you have the same sum, you have a same infinite series. In the third case, you have the same infinite series, and so on. Okay, so you have same expression. You can write and simplify 1 minus a whole cube. That's the answer. So let's go to check the answer. Yeah, you have option 1A, first option. Okay, so that's the use of the summation and the infinite GP series. Okay, next let me go to the number 5, question number 5 once again. So you have, first you observe, if the sum to infinity of the series 1 plus 4x plus 7x square plus 10x cube plus etc. is 35 by 16, where mod x less than 1, then x equals, you have to find out the x. First you observe the series very carefully, 1, 4, 7, 10. This is in AP, and 1 x, x squared x cube. This is in GP. So it is AGP, arithmetico-geometric progression. This is a AGP series. That is your first observation. Now, how to get the sum? That is the question. First observation is you have to identify the AGP series, arithmetico-geometric progression series. Okay. So I will solve this. Yeah. So 1 plus 4x plus 7x square plus 10x cube. That is the series. Okay. So I'm writing this as S. First thing. 1 plus 4x plus 7x squared plus 10x cubed plus etc. Again writing is, I am multiplying that x is by this sum throughout by x. I am multiplying throughout by x and writing like this, just keeping one space free. So x, next term will be 4x squared, to get the difference actually, 7x cubed and so on. That's on. So if you subtract s into 1 minus x equal to 1 minus 3x, 1 plus 3x, okay, you are subtracting 3x squared plus 3x cubed and so on. Okay, so only except 3, all the terms are in infinite GP. If you take 3x, 1 plus x squared, etc., this is in infinite GP because mod x is less than 1, because you see mod x is less than 1, so you can apply the sum of the infinite GP. So 1 plus 3x into 1 minus 1 over 1 minus x. So if you simplify and if you take s, this 1 minus x cross multiplied, if you simplify, you will get 1 plus 2x over 1 minus x whole square. And this sum is given in the question. You see, the sum is given as 35 by 16. So you can write this is as 35 by 16 and solve for x. If you solve for x, already I have solved. So it's two factors you have, 5x minus 1 into 7x minus 19 equal to 0. If you cross multiply and simplify, so your answer will be 1 by 5, because 19 by 7 it will be more than 1 and your mod x should be less than 1. Your mod x should be less than 1, so x gonna be 1 by 5. That is your answer. Okay, so that is the use of the infinite, it's specially AGP, arithmetical geometric progression. Then we are using infinite GP. So that is the use of AGP. In AGP, arithmetical geometric progression, we used to write s in this type and we have to multiply the s with x and then do the simplification. Okay, let's move to the next problem. Yeah, so now this type of problems are also very important for mains and advanced, because you sometimes in trigonometry, in algebra, in whatever sort of, in calculus, you have to find out the minimum value or maximum value. So if there is a question of minimum value and maximum value, we have to think about that there is a relationship between AP and GP, that is AM greater equal to GM greater equal to HM. That is the main relation. That is arithmetic mean greater equal to geometric mean greater equal to harmonic mean. We can use this, and this equality holds when the numbers are equal actually. So I'm going to use this technique. So you can easily see that 1 by a to the power 4 is one of the number and 1 by 4 b to the power 4 is another number. So if I apply that technique here, 1 by a to the power 4. So I am considering two numbers actually, 1 by a to the power 4 and 1 by 4 b to the power 4. So let me write here. So let's take two positive numbers, 1 over a to the power 4 plus 1 over 4 b to the power. So I'm applying AM greater equal to GM only. Arithmetic mean greater equal to geometric mean. So what is that? That is basically a plus b over 2 is the arithmetic mean greater equal to square root of ab. If you take two numbers, If you take three numbers, it's gonna be a plus b plus c by 2 greater equal to root over abc. So that's the technique. So I'm considering two numbers only, 1 by a to the power 4 and 1 by 4 b to the power 4. So taking the sum, and that's greater equal to square root of 1 by a to the power 4 1 by a to the power 4 and 1 by 4 b to the power 4, the product. Okay, now you have a thing that ab is 1. It is given that ab is 1, so a to the power 4 b to the power 4 will be 1. So that's equal 1 over a to the power 4 plus 1 over 4 b to the power 4 greater equal to 2 into this square root will be half. And using the fact that AB equal to 1, I'm using that fact. So it's 1, it's greater equal to 1. Okay, so the minimum value is 1. So the minimum value is 1 using the AM greater equal to GM technique. This you have to observe, and you could use this. If you can identify the problem, you can easily. So option 1. So this type of problems are very interesting and very important. Let me use another problem, another technique of this. Yeah, this is trigonometrical problem. You can use trigonometry, you can use AMGM. So AMGM, HM, that will be very helpful, very helpful. So its fx is cos square x plus sec x by 4. You have to find out the minimum value of this. That means greater or equal to. And x is given in minus pi by 2 to pi by 2. That's the range of x. So that is also a very important observation. In this range, why I have taken this range? Because cos x is positive. You see, if you see the diagram of cos x, so this is cos x will be like this. You see, this is pi by 2 and this is minus pi by 2. Okay, this is minus pi by 2. You see, in this range, minus pi by 2 to pi by 2, cos x is positive. So that is why this interval is given. So whenever there is an interval is given in the problem, there must be some reason behind that. So you have to find out the reason. So this is the first reason, that cos x is greater than 0. So you can apply AM greater equal to GM, because AM greater equal to GM greater equal to HM can be applied for positive numbers. So let us apply. Yeah, let me add a page here. Yeah. So I have cos square x plus sec x by 4. So you can write cos square x, one more observation, plus 1 by 4 cos x. So one more observation is that if you apply AM greater equal to GM, that's fine, you are getting this sum. But if you do the product, cos square is cos not cancelled. One cos is remaining in the numerator. This is very important observation. So you have to do some another thing, another short trick. So I'll apply that trick. So let me write the fx here. Your fx is cos square x and plus 1 by 4 cos x. Okay, now I am writing, I need to cancel cos square x anyhow, otherwise I cannot find out the minimum value. So cos square x plus, I am writing 1 by 8 cos x plus 1 by 8 cos x. So I am taking three numbers. Actually what I am doing, I am splitting 1 by 4 cos x into two parts actually. 1 by 8 cos x, 1 by 8 cos x. You take the sum of these two, you will get 1 by 4. So that's the technique actually. You have to observe. If you apply AM greater equal to GM, you have to apply in such a way that on the right, if you apply GM, the trigonometric function will be cancelled, and you will have a pure number, so that you can get the maximum or minimum value. That's the technique actually. That's the target. So now you apply AM greater equal to GM. So I'm considering three numbers and also applying AM greater equal to GM. So considering three positive numbers, one of them is cos square x, another one is 1 by 8 cos x, another one is 1 by 8 cos x. Three numbers. So it will be divided by 3, they are AI, and greater equal to, you take the cube root. So cos square x times 1 by 8 cos x times 1 by 8 cos x whole to the power 1/3 cube root. You have three numbers, so it's gonna be 1 by 64 to the power 1/3, and that is equal to 1/4. Okay, so look at that. My target is fulfilled because cos square is cancelled. I have a pure number on the right. So now I can write cos square x plus 1/4 of cos x greater equal to 3 by 4. I'm just transposing this 3 on the right, cross multiplying. So your minimum value of the function is, this is your function actually, minimum value of the function is 3 by 4. So let's check. Yeah, you have your option B. That's the target you are using. If you can use in trigonometric problems, you can use in the calculus, you can always use in the algebra. Okay, so now today's last problem in my lecture, that is very advanced level problem. Just let me show you. It's not easy. Look at that. Look at the problem first. First of all, you have one ABC are positive real numbers such that a plus b plus c equal to 18. Find the maximum value of a square b cube c to the power 4. Okay, so its identification, its observation is not so easy for this problem. So I will use here weighted arithmetic mean, weighted geometric mean. So before that I will explain what is weighted arithmetic mean. So what is weighted arithmetic mean is basically the weight. Some frequencies are attached. Weighted AM. Weighted AM is basically, suppose you have n numbers A1, A2, AN, and they have a weight M1. So their AM will be A1 M1 plus A2 M2, etc. plus AN AM MN over what is the total weight? Total weight or frequency. Actually, weight means frequency. Total weight is M1 plus M2, etc. Mn. That's the total weight. Okay, so you have to divide the weighted, you have to get the weighted arithmetic. How? A1 M1, M1 is the weight of A1, M2 is the weight of A2, or frequency, Mn is the weight of An, and the total weight will be, total frequency will be M1 plus M2 plus Mn. That is the weighted arithmetic mean. And what about weighted geometric mean? Weighted geometric mean, similarly you can explain like this: A1 to the power M1, A2 to the power M2, etc. An to the power Mn whole to the power 1 over M1, the total weight, 1 over the total weight, total frequency. That's the GM, weighted arithmetic mean and weighted GM. So I am going to use that. Now how? Look at your problem. First observation is that you have ABC equal to 18 and you have A squared. So I'm writing A by 2 into 2. If I take the number as A by 2 and the weight is 2, 2 get cancelled. Okay, plus if I take the number b by 3 and take the weight as 3 or frequency as 3, then 3 get cancelled, you will get b. Lastly, if I take the number c by 4 and take the weight 4, then 4 get cancelled. That is your first observation. And if you take the weight in the geometric mean also, so it will be a by 2 whole square because the weight is 2. It will be b by 3 whole cube because the weight is 3. It will be c by 4 whole to the power 4 because the weight is 4. So that will give you this term. I want this term. Actually, this term is the product and you have an addition here. So you have a product and you have an addition. That means you have to use AM greater equal to GM. Not only simple AM greater equal to GM, but you have to take weighted arithmetic mean and weighted geometric mean. So let me write. So I'm considering three numbers, a by 2, b by 3 and c by 4 with weights corresponding weights or frequency 2, 3 and 4 respectively, with corresponding weights. Now I am applying weighted arithmetic mean greater equal to weighted geometric mean. I'm going to apply. So that's gonna be a by 2 times 2 plus b by 3 times 3 plus c by 4 times 4 over what is the total frequency or total weight 2 plus 3 plus 4 greater equal to a by 2 whole squared. I'm applying weighted GM, b by 3 whole to the power cubed, c by 4 whole to the power 4 over 1 over 10, 1 over 10. Oh, sorry, 1 over 9. That's my mistake. It will be 1 over 9. Yeah, it's gonna be 9. So look at that. Your numerator on the left will be a plus b plus c, and that is 18. 18 by 9, because it's given in the problem. You look at that, a plus b plus c is 18. So it's 18 by 9 greater equal to, you have a squared b cube, a cube, b cube and c to the power 4 over 2 squared 3 to the power cubed and 4 to the power 4 whole to the power 1 by 9. So it's 2 to the power 9. So you can write a squared b cubed c to the power 4 if you want to simplify. So let's take that side, 2 to the power 9 into 2 squared 3 cubed into 4 to the power 4. Okay, so that is equal to, if you simplify, that is equal to 2 to the power 19 into 3 cubed. So the maximum value of a square b cube c to the power 4 equal to 2 to the power 19 into 3 cube, 2 to the power 19 into 3 cube, 2 to the power 19 into 3 cube. Okay, so let's check for options. Yeah, this is option B. So this is the more advanced level where you are using weighted arithmetic mean and weighted geometry. In the simple problems you can apply arithmetic mean, geometric mean, but in the more advanced level you have to identify the number. You have to guess the number from the positive number from the problem, a by 2, b by 3 and c by 4. Okay everybody, so that is the problem, and that is a very very important concept. Weighted arithmetic mean is equal to weighted geometric mean. So that's all for today in this presentation. Thank you all of you.